Okay, so today what we're going to do is we're going to begin our talk about the analysis portion of your inference paper. Remember, we already talked about how you're simply going to take the data set, the electronic data set that we give you, you're going to copy and paste it right into NZ-Grapher, and then just all you have to do is select the columns you want and the information you want, and it will automatically draw the graphs for you. That is a huge deal, okay? It takes a full day's work off this test or this assessment because you don't have to organize the data, then import it into an Excel spreadsheet, and then do it. You can copy and paste it right into it. So we've talked about that. We will also talk about it again right before we have to do it. So remember, your assignment was to take a data set and see if you could import it in and try that and give it a shot so that you know you can make it work. So if you haven't done that yet, because you were very involved in what you were in your mocks, that's fine, but let's get it done, okay? Make sure that you can take a data set, and you have some from your OneNote, take a data set, import it into OneNote, and create those box and whisker plots that you need, okay? All right, so then after you've done that, then you're going to have to look at that data and then make an analysis of it, okay? So let's begin, though, by talking about what an inference is, because I don't know that we've really defined it. When you're making an inference, what you're making is like a hypothesis, right? Which is an educated guess. It's an opinion based on past facts, right? And that's just my own wording of it. You can word it another way. So if everyone in here made an excellence on the questionnaire paper, then what could you infer about next year's Year 12 stats class when they do the questionnaire paper?
They'll do well on it.
They'll do well on it. They should probably make excellence on it, right? If not all else being the same. If everyone in here did, right? If no one in here made excellence, then what could you infer about that paper for the next year? That probably the excellence level is going to be very low in that, right? So what we're talking about is an inference. Now, are they guaranteed to make an excellence if y'all do? No, right? Because y'all are just way smarter than they are anyway. So, right? So that's the way it works with an inference. You're basing, right, your information on something that's happened in the past. Now, and remember, we're not going to be using the entire information from the population. We're going to be using what's called a sample, right, of the data, because it's almost impossible to get a true population comparison. So we're comparing using a sample, which means that the inference we make may be even more fuzzy. Yeah? Okay? So keep that in mind. This is not a fact. This is an inference. Okay? All right. So what we're going to do today is we're going to look at a lesson about shift. Now, you know what the word shift means. If you shift something, that means you move it from one side to or the other. Yeah? So you're moving back and forth. And that's what we're going and that's one of the critical pieces of analysis that you can do when you have a box and whisker plot. And one of the reasons that I love this Education Perfect exercise so much is they are literally using an NZ-Grapher example. So it will look identical to the one you create. All right? All you have to do is know where to get the information and how to write it up. Today, all we're going to do is look at what shift means and how you can determine if there has been a shift. Because there's not always a shift. Could you have the exact same or the same kind of data from this class and the class next door if you're taking the same thing? Yeah, it could happen, and it usually does, right? Okay, so there's not always going to be a shift, but that's fine. If there is no shift, you can still describe shift. What you'll be just saying is that there was, not one. Okay? And this is why there was not one. So even if there isn't a big shift in your data, then you can still describe shift as not happening. But you have to be able to learn how to describe it. So what we're going to do today is we're going to look at it. Now, I'm going to tell you that that shift is not just a little movement. It's a specific mathematical thing. So you have to think about that. And it can look complicated, but it's not. Right? So I'm going to do a lot of drawing on here just to show you what a shift looks like. All right, so let's go to the lesson. Okay, and again, this is all assigned to you, including the parts that I'm going through in class. Also, remember that I'm recording these, so they're out there for you if you need them. So, today we're going to talk about understanding shift. So, after completing this lesson, you should be able to identify the median or quartile shift between two sample groups. Remember, median means the number where? In the middle. Quartiles, how many quartiles are there? 4, right? Remember when you have the box and whisker plot, that box contains how many of the quartiles? 2, and then the whiskers are the other 2, right? Okay? Each one of those sections contains what percentage of the data? 25%, excellent, right? Because it's got to all add up to 100% of the data. Good, and we'll look at some of that. You must justify your answer by providing numbers from the summary statistics, which is going to be given to you, so you don't even have to think about those numbers or to get those numbers. You just have to read them and know which numbers to use. Okay? And you must relate your observation back to the context. Now, again, we're not going to talk about that so much today. We're going to talk about that next time. But for today, we're just going to do the first one and look at where those numbers are coming from. Then we'll do how to do the analysis next time. Okay? Now, refers back to the PPDAC. Remember that plan, blah, 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 right? That cycle of inquiry that we've talked about. The book gives it in a circle. This one just gives it as there. And you can go back and look at that. If you want to, it should be in your notes. And you can also look at it through Education Perfect. It's fine. All right. So you're going to learn about shift, which is used to compare the distribution of two sample groups. And that's how you make an inference. I can infer that the 15-year-old boys are taller than 15-year-old girls, right? Based on the data, right? Could be true, could be not true. So that kind of comparison. Remember, we're making a comparison. Remember your sentence that you made? It has to have median, and you have to have two groups, and you have to describe your population. Sounding familiar? Okay? All right. So shift measures the distance between two corresponding graph features. So we're going to have exactly the same graph, and you're just talking about how they compare to each other. And you're going to be looking at the median, the minimum, the upper and lower quartiles, depending on how they're distributed. Shift can be either shift left or right. So you'll see they're having this purple one move all over the place, right? Showing you that they can be identical or they can be shorter on one side, shorter on another side. We're going to look at examples of all of that. But determining which features are shifted gives you a really good example of how the data is distributed. And how the data is distributed is one of the things that makes you, that can make you be able to make your inference, right? Okay. So for this particular standard, you compared two things that are very important: the median shift and the quartile shift. So if I were you, I would write that down, do something so that you know that those are the two big types of shifts that we're going to be talking about. Which one is the median? It's the line in the middle, right? Okay? In the middle of the box. Well, actually, does it have to be in the middle of the box? No, it can be spread out. So this one is kind of off to the right a little bit, yeah? And the quartile. Remember the quartiles? That just means those upper and lower quartiles, right? The median is actually a quartile as well, isn't it? It's quartile 2. All right. But those shifts. So we're going to have some look about these observations because they give you the most information, right? You could actually compare any part of this. But you'd have to have the specific data in order to be able to do that. So it makes your life a lot easier if you go with these pieces that we know, right? And again, you're going to see in a moment that that summary is already done for you. And so you know what each of those numbers is. Okay? So the median shift, what do you imagine? Just the difference in the median value. Yeah? It's either to the right. One median is either to the right or the left of one, or they can be what? Exactly the same. Yeah? So if you look at this particular example, here's the median for the purple one. Here's the median for the blue one. Notice that the median for the blue one is way far to the right compared to the one for the median on the right. Okay? Now, the position is what makes it a shift, though. If you had two boxes, and the median of this one is here and the median of that one is there, that's not showing a shift. Because look how close they are together. So don't think that any movement is a shift. Okay? It's a specific amount of movement that's a shift. And that's what we're going to talk about in this lesson. How do you determine how much movement is a shift and how much just means the median is a little higher in one than the other? Okay? Now this one is a definite shift because if you look at it, the median of this one and the median of this one, notice that the median of this blue one is beyond Q3, the upper quartile, isn't it? So it is a full 25% bigger than the median of the other. Does that make sense? That makes it a shift. If the median was here, would it be a shift? No, because it's not a full 25% more. Okay? Now, there's a mathematical way to find it, and we're going to talk about that. And it doesn't involve much math. It involves counting. If you can count, you can do it. And we'll talk about that as well. Okay?
Sorry, is it just 25% or can it be more?
It can be more. Yes, 25% or more. But don't write that down because well, if it goes beyond one of the other lines. So like here's Q3. Does the median of the line below that fall above the Q3 line of the other one? Yes, because here's Q3 line, that dotted line I just made. Right? And here's the median. So it's above that, higher than that. Because the further you go right, the higher the number is. So that means that, yes, there has been shift. It doesn't. It just has to be past one of those lines, yeah. Because that means it's past more than 25%. Okay? All right. Now that's all we're going to look at, guys, is how to determine if there's been a shift today. So don't worry if it makes any sense. And here's what I'm talking about. Oh, there's a desk right outside the door if you want to grab it. Sorry. I think there's a chair and a desk. No?
We have to grab one of the desk and chairs and I grab those chairs. I'll just tell you that.
One of the reasons I love this lesson is if you look at this is an exact replica of what you're going to get on NZ Grapher. So when you do the graph, once you import your data and select your two sets of data that you're going to be comparing, and you label it, right? This label and these labels will automatically appear because you imported the data, but you have to give it a title, right? And the way you import it, sometimes it even imports that bit, but you have to have a title. So again, we'll talk about the graphs later, but do not forget that everything has to be titled and everything must be labeled. Now again, the way we're going to be importing these, it's going to import those labels for you. Whereas before, you would have had to go in and alter the graph. You're welcome. It's good to be addicted to YouTube, for your teacher to be addicted to YouTube. Okay, so notice also that you have all these numbers here. I know they're pretty small, but don't worry about that because you'll be looking at them closely. Those are the summary statistics. notice it gives you minimums. It gives you first quartile, median, the mean, upper quartile, the max for both graphs. So they're easy to compare. And here, they've highlighted these two in blue because those are the two medians. The top one is the median for this graph. The lower one is the median for that graph. Okay? Now notice that the median for this graph is way to the right of the median of the other one. Is it not? Okay? And if you look at this, here is the line for the upper quartile for the bottom graph. Do you agree? That means that there is a definite shift for the medians. This median is above another one of the measures. As long as one line is bigger than the other, that median is above the upper quartile, which means that there's a shift. Okay? Don't make it more complicated. It's not. Just draw the line and see if that's happening.
Does it always have to be above?
Well, you could say that, or you could say that that one is above, but we could also say that this one is below. So you can go either way. Depends on what you're trying to prove. Am I trying to prove that the yes one is lower than the no one, or am I trying to prove that the no one is higher than the yes one? Sorry? What the heck did I do? Okay. All right. Sorry about that. All right. So this median has a definite shift below the top one, right? This median has a definite shift above the bottom one. Okay? So yes, again, it's going to be what you're trying to prove. Are you trying to prove that girls are smarter than boys? Right? Then that's the one you'll look at. If you're trying to prove that boys are not as smart as girls, then that's the one you're going to look at, right? It's your perspective. It's based on the question that you asked in the beginning. That's the one you want to know the shift of. Okay? Is it proving your point or is it not proving your point? So here they're talking about mother's age by birth weight. So there's birth weight of the babies. Does it depend on the age of the mother? And if you look, the median mother's age for non-low birth weight is greater than the median for low birth weight. So for the two categories, this one is not low. This one was low. And if you look at the age here, okay, you can compare the two. And we'll talk about writing the analysis later. All I want you to see right now is that you can make those comparisons, right? This is just reminding you that each one of those boxes represents how much of the data? 25%. So if it was 200 total points, and each one is 25%, that's 200 divided by 4, right? Which means that each one of these represents 50 pieces of data. That's important because for you to make a proper analysis, you need to say 50 of the people in the survey, right? You need to support it with numbers and that you understand not only what the graph looks like, but what it means. That's the difference between merit and excellence right there. So this means that 50 of the people were taller or whatever. Okay? So make sure you know that you need to in your analysis, you need to include those things. So here we go. A quartile shift. Now this is different than the median shift. A median shift means that the median is further than is above at least the upper quartile, or below at least the lower quartile. The median could be above the maximum point, and that would still show shift. Okay? So, but for quartile shifts, we're just talking about one quartile being bigger than one other. So here, if you just look at these two, here is the maximum, and here is the upper quartile, right? Is this upper quartile further over to the right than the maximum of the other one? Yeah. Therefore, there's been a quartile shift. Now, is the median of the blue one above the upper quartile of the purple one? No. So has there been a median shift? No, but there has been a, what is it called? Quartile shift. Okay? So the same idea, but we're not talking about the median this time, we're talking about a quartile shift. And a quartile shift is still significant. All right? So you can have median shift or you can have quartile shift. And they mean exactly the same thing. Okay? If one of them is further than one of the ones above it or below it, then you have a shift. Make sense? Okay. This is a critical point. You must understand where these are coming from because this is one of the things that we're going to be looking at when we grade it. Did you talk about shift? And if you didn't, and support it with numbers, then we can't count that one, right? 3 for excellence, 2 for merit, 1 for achieved. But it has to be supported with the numbers. Okay? All right. Now, so here we can say that the upper quartile, right? The upper quartile of the blue is shifted above to the right of all the data points in the purple group. So the upper quartile here has gone beyond all of the data in the purple group. So it kind of addresses what, yes, it can go way further than just one quartile further, right? All right? Okay. So here you go. You have a little graphic. If you look at what they're doing, see right here at the upper quartiles, if it goes even the slightest bit above the next one, then there's a quartile shift. Okay? But if it's not, then there's no quartile shift. Okay? If they're within each other, within the range of each other, then they're not. But if they move beyond, then they are. Okay? Now here's where they give the math. A quartile shift occurs when the number of quartiles you're comparing add to more than 4. So that means that the ones you're looking at have to add to more than 4. Now don't worry about all these different definitions. You know that when things add to more than 4, that means they add up to at least what? 5. It's got to be add up to 5. And for some reason, they think it's important to show you that how different things can add up to 5. You just look worried about if they add up to 5. So let's just look at here, this one. Okay? For example, consider the following. Here, the upper 3 quartiles of the non-low birth weight are shifted to the right of the lower 3 quartiles of the birth weight. This means that the oldest 75% of the women gave birth to a baby that wasn't low weight were all older than the youngest 75% who gave birth to a low weight baby. So in this sample. So if you look at the data here, again, don't worry about the conclusion that they're making. Okay? Here's one quartile. Yes? Here's another quartile. Right? Here's a third. Okay? And all of those fit into what? The first one on the upper one. Okay? So every one of those. So that's showing a huge quartile shift. Do you agree? Okay. Now, what we're comparing is right here. This is the first part of the line that goes beyond the others. So that's 4 things below that one thing. Okay? So that comparison of 4 things to that one thing gives you the magic total. Okay? All right. You're going to do exercises where you're going to be comparing these, so you're going to have a chance to count these up and do them. So here you go. Which one of them, either A or B, shows a quartile shift between the 2 groups? If you look at the first one, is there a quartile shift here? Those, okay. Remember, you can draw lines to help you see. That's hitting into there. So that's not way above. That's not above one quartile, right? Okay. That's hitting there. That's hitting there. So is it showing a quartile shift there? No. Now, look at the bottom one. So that one?
That one isn't.
No, but which one is?
That one.
There we go. This one, if you look at this one, this measure is beyond the mean of the other one. Okay? So let's look at and make sure we got that right. Okay? A does not have a quartile shift between groups. Okay? If you look, all of these quartiles fall within another quartile. But B, if you look at this one, this whole quartile, okay, this whole quartile here is, can't draw the right line place. Let me try that again. This whole quartile here happens before you get to the lower quartile there. Right? So that indicates a quartile shift. Okay? As long as that one whole quartile happens before. Okay? And again, you're going to practice this in an exercise. Okay. And actually, yeah, there's where your exercises begin. Okay? All right, so again, we're just going to be talking about the quartile shift here and what it means and how to identify that there is one. And then next time we meet, we're going to be talking about the analysis. Okay?